Greetings, everyone. I am UDAY Sharma from the AAA Department of Institute of Aeronautical Engineering. Today, I am going to discuss about the ring oscillator. Oscillators are basically used to convert the direct current or DC currents from a power supply to alternating AC signal. That is, when a DC is provided to oscillator, AC output is given. It is widely used in electronic devices. Ring oscillators are commonly used in many systems because of their wide tuning range, compact layout, and ability to generate multiple phases. These advantages over inductance capacitance or LG oscillators come at the cost of phase noise. In other words, a ring oscillator is a device composed of an odd number of NOT gates in a ring whose output oscillates between two voltage levels, representing true and false. The NOT gates are inverters are attached in a chain, and the output of the last inverter is fed back into the first. The NOT gates are fed back, and the signal from the last NOT gate is fed back again. Let us discuss the basic structure of this ring oscillator. In its simplest form, a ring oscillator comprises n gain stages, that is, n number of gain stages in a loop with negative feedback at low frequencies to avoid latch-up. If each stage inverts, the n or n number of gain stages is odd. A rising edge at a node within the loop travels through n inverters and returns as a falling edge, forming one half of the oscillation period T0. That is, a rising edge at a node with a loop travels through n inverters. A rising edge traveling through n inverters returns as falling edge. Rising edge through n inverters returns as falling edge, forming one half of the oscillation. Forms one half of the oscillation. This is a half of oscillation. Period T0 over a time period of T0. Thus, T0 is equals to 2n TD, where TD denotes the large signal gate delay. Here we can see a ring oscillator consisting of n inverters, each inverter containing a NOT gate. N number of inverters are connected. These n inverters form a single ring oscillator. First, since the delay of an inverter falls as the supply voltage VDD increases, as the delay decreases, the supply voltage increases. The oscillation frequency F0 is inversely proportional to VDD. F0 is inversely proportional to VDD. This supply sensitivity K of VDD proves serious as noise on VDD directly modulates the output frequency. Second, for a total load capacitance of CL at each node, the average power drawn from VDD is approximately equals to NF0 CL V square DD, or NF naught CL VDD square. Third, an n-stage ring provides n output phases with a minimum separation of TD seconds due to the inversion in each stage. The actual phase difference is minus pi plus pi by n. We can see this as the n stages ring provides n output phases with minimum separation. Due to this, there is an inversion in each stage. As the n output phases with minimum delay, there is an inversion in each stage. The problem of supply noise can be greatly elevated through use of differential rings. In an implementation, we prefer that the differential pairs experience nearly complete switching and hence produce a single-ended voltage swing. To this end, we select these transistors wide enough so that with an input voltage difference of ISSRD, one transistor turns off. However, a ring consisting of only 3 stages does not provide complete switching because the delay through loop is too short to allow Vx and Vy to reach VDD. The delay through loop is too short to allow Vx and Vy to reach the VDD. It can be shown that the maximum swing is approximately 0.5 IRSSB. In the case for reasonable supply rejection, the tail current source must operate in the saturation region. That is, for reasonable supply rejection, the tail current operates in saturation region. Another advantage of differential ring is that they can provide multiple phases having a minimum spacing equal to pi divided by an equal number. This is possible because in differential ring with an even n can have still negative feedback at low frequencies. We can use the differential rings that they can provide multiple number of phases with only minimum spacing. As we can see here, the apparatus containing only minimum components of resistors and capacitors. The outputs of the supply VDD, the Vin and Vin. Now, let us discuss the applications of the ring oscillator and how the ring oscillators are used. The first application is the voltage controlled oscillator. In most phase log loops is built from a ring oscillator. That is, the voltage controlled oscillator, the oscillator, the voltage controlled oscillator. In most of the phases containing the locked loops is built from a ring oscillator. Jitter of the ring oscillators is commonly used in hardware random number generators. A ring oscillator is sometimes used to demonstrate a new hardware technology, analogous to the way a Hello World program is often used to demonstrate a new software. Like that is, a ring oscillator is a basic oscillator which is used to demonstrate a hardware, as we use Hello World program as a basic program to show a software. Many wafers include a ring oscillator as part of the scribe blindly test. They are used during wafer testing to measure the effects of manufacturing process variations. Ring oscillators can also be used to measure the effects of voltage and temperature on a chip. Thank you. This is Uday Sharma signing off.